Now, we're going to move the player game object. First, let's think through how we want this player game object to behave. We want to have the player fly around the game area, stay on the play field, and not fly off into space. We want to be able to collide with our collectible game objects and pick them up when we do this. This requires physics. Unity has two physics systems, one for 2D and one for 3D. These systems are comparable to each other and compatible with each other in that they can both be in the same scene, but importantly, they will not interact with each other. For this project, we'll be using 2D physics. To use 2D physics, the game object needs to have a rigid body 2D component attached. To attach a new component, we must first select the game object we want to attach the component to. In this case, we'll select our player game object. Then we can either choose the component menu and select Physics 2D, Rigid Body 2D, which would attach this component to the game object we've selected, or use the Add Component button in the inspector, choosing Rigid Body 2D. It's important to be sure that we're adding the Physics 2D version of this component, not the Physics or 3D version, since we can choose between both the Rigid Body component for 3D physics and the Rigid Body 2D component. These components cannot work together, so be sure to choose the correct components for our game type. If we choose to, we can rearrange the order of the components on the game object using the context-sensitive gear menu in the upper right of the component. Doing this has no effect on the performance of our game. However, having a consistent order to the components on our game object may help us speed up our development by keeping or maintaining an organized project and hierarchy. Don't forget, we can collapse or expand the component view by clicking on the component's title bar. Now, we need to get the player object moving under our control. To do this, we need to get input from our player through the keyboard, and we need to apply that input to the player game object as forces to move the player object in the scene. We'll do this by using a script that we attach to the player game object. Let's create a new C# script. To create a new script, we have some choices. We can choose Assets, Create to create our new C# script, or we can use the Create menu in the project view. But what might be more efficient in this case would be to select the player game object and use the Add Component button in the inspector. The Add Component menu contains the selection New Script. This allows us to both create and attach a script in one step. First, let's name this script Player Controller. We can choose the language of the script, which will be C#, and then click on Create and Add, or simply hit the Return or Enter key to confirm our selection. Unity will create, compile, and attach this script to the selected game object. We should note that this way of creating a script will create that script asset on the root or top level of our project view. We'll need to move the asset into the scripts directory in order to maintain an organized project view. If we select the script in our project view, we see a preview of the script asset in the inspector, but this text is not editable. Let's open the script for editing. We can do this in a number of ways. When we're inspecting a game object with the script attached, we can use the context-sensitive gear menu. We can double-click on the script asset in the project view, or we can use the Open button in the inspector when we have the script selected in our project view. This will open our script in our preferred script editor. First, let's remove the sample code provided in the base script. Next, let's think, what do we want to do with this script? We want to check every frame for player input, and then we want to apply that input to the player game object every frame as movement. Where will we check for and apply this input? We have two choices, update and fixed update. Update is called before rendering a frame, and this is where most of our game code will go. Fixed update, on the other hand, is called just before performing any physics calculations, and this is where our physics code will go. We'll be moving our UFO by applying forces to the rigid body 2D, meaning that this is physics. The fact that it's 2D physics as distinct from 3D physics, in this case, is irrelevant. We're going to put our code in fixed update. The next question is, what code are we going to want to put in fixed update? We know that we need input, but how do we find out more? There's a shortcut in MonoDevelop that searches the Unity API. On the Mac, it's Command plus single quote, and on Windows, it's Control plus single quote. Select the item we want to research, in our case input, and hold down the Command or Control key and then press the single quote key. This search brings up every reference in our documentation related to input. Let's select Input at the top, Interface into the Input System. This brings up the page on Input. This is the page on the Input class. We use this class to read the axis setup in the Input Manager and to access multi-touch and accelerometer data on mobile devices. We read the text on the top of the page to understand how to use the class, in our case, to get input from the player on all platforms, including mobile devices. Under the description is a list of class variables and class functions. The class variables hold information like the number of touches in touch count or a reference to the default gyroscope with gyro. The class functions do something for us. In our case, we'll be using input.getAxis. When we find the item we want, we click on the link to bring up a page on the function or variable. Let's look at input.getAxis. This page includes the signature of the function, a description of the function, and code snippets showing us how to use it in Unity's JavaScript and C#. We will be using C#. For more information on input and the Input Manager, please see the information link below. We'll be using input.getAxis in a very similar way to the code snippet shown. Let's return to our script and write our code. Type float move horizontal equals input.getAxis horizontal, float move vertical equals input.getAxis vertical. Now we can delete the input line. This grabs the input from our player through the keyboard. The float variables move horizontal and move vertical record the input from the horizontal and vertical axes, which are controlled by the keys on the keyboard. These keys are set by default in the Input Manager. Our player game object uses a rigid body 2D and interacts with the 2D physics engine. We'll use this input to add forces to the rigid body 2D and move the player game object in the scene. To know more about how to apply forces to the rigid body 2D, let's check the documentation. First, type rigid body 2D into our script. Now, select rigid body 2D and hold down the Command key on the Mac or the Control key on Windows and type single quote. Again, this brings us to a page with a search term rigid body 2D. Let's click on that. This brings up the rigid body 2D page. If we want to apply force to our player game object, we need to do something. So let's take a look at the functions available to the rigid body 2D class. We can read the descriptions until we find the one we want. In this case, let's choose Add Force. This adds force to the rigid body 2D. As a result, it will start moving. Click the link and we go to the page on Add Force. We can see the signature of the function at the top of the page. The signature tells us we need a vector 2 and an optional force mode to add force to our rigid body 2D. What is a vector 2? For more detailed information on vector 2, please see the information link below. But in simple terms, the vector 2 holds 2 decimal values in one container. This makes it easy for us to move around and use values for things like a force in 2D space, which requires a value for force on both the x and y axes. All of our documentation pages are linked together. If we were to click on vector 2, we would be taken to the documentation page for vector 2. The next concept that we need to cover is how to get a hold of or how to reference different components on our game object. We're currently writing a script called Player Controller, which is attached as a script component to our player game object. From this script, we need to add force using the rigid body 2D component. We want to access that component from this script. There are several ways that we can do this, but in our case, we'll cover only one of the main ways of accessing another component on the same game object. We'll create a variable to hold this reference in our script, and we'll set this reference in the start function. Let's return to our script. In our script, we need to write private rigid body 2D, RB2D, to create the variable to hold the reference. We're going to declare a new start function, and in it, we're going to write RB2D equals getComponent rigid body 2D. In fixed update, let's use rigid body 2D.addForce with a vector 2, and we'll leave the force mode at default by omitting it from our code. So in our script, we need to type rb2d.addForce and then some vector 2 value. Now, how do we get our two float values into a vector 2 value? Let's create a new vector 2 variable called movement. This will be equal to a new vector 2 that's made up of an x and a y. The x and y values will determine the direction of the force we will add to our UFO. What is our x value? That would be move horizontal. With this, our left and right keys will add force, moving the UFO to the left or right. What is our y? That would be move vertical. Now we use movement, our new vector 2 value, in rb2d.addForce as rb2d.addForce movement. Let's save this script and return to Unity. We can check for errors in our footer or the console, and there are none. Good. Now, let's test what we've written. Hit play. The first thing we'll notice is that the player immediately flies downward off the playing field. This is because the default for our rigid body 2D is to apply gravity downwards along the y-axis. Since our game is designed as a top-down view, this doesn't make any sense. Exit play mode. To eliminate this behavior, we'll set the gravity scale property of our rigid body 2D attached to our player to 0. This means that no gravity will be applied. This is one reason why making a top-down 2D game is a little easier, because we don't have to deal with gravity in our physics. Now, play again and test. By using the keys set up in the input manager, the UFO moves in the scene. Gravity's now off, but the player is still very slow. This is probably too slow to be playable, but the basic concept works 100%. To stop testing, exit play mode. Let's return to our code and create a tool that will give us control over the speed of the UFO. We need to multiply our movement by some value. We could simply enter that value here on our script, but if we ever needed to make any tweaks or changes, we would have to return to our scripting editor and change the value in the script and then recompile. This would take time. The solution is to create a public variable in our script. Let's create a public float called speed. By creating a public variable in our script, this variable will show up in the inspector as an editable property. When we use a public variable, we can make all of our changes in the editor. Let's now multiply movement by speed. We can use this to control our movement value from inside the editor. Let's save these changes and return to Unity. When we return to the editor, we can see our player controller script now has a speed property. Let's set this property to 1000. Play the scene and test. It works, but the player is moving way too fast. But changes are fast too. Let's exit play mode and let's change the value to 10. That's better. Congratulations, we can now move our player character. You'll notice, however, that the player can just fly through the walls, which is not what we want. In the next lesson, we'll add collision detection.